All right, here are solutions for quiz 8 for Math 95. We got two problems here. In the first one, we're given an equation, specifically a radical equation, and asked to solve it. So basically what you need to know is this wouldn't be too hard to solve if it weren't for this radical, this square root sign. Unfortunately, we can get rid of the square root sign. However, to do so, we have to isolate it. So our first step is to get this square root sign all by itself. What I mean is add 1 to both sides of the equation. That would give us the square root of x plus 7 equals x plus 1. And the way we get rid of this square root sign is by squaring both sides of the equation. So the square root of x plus 7 squared is just x plus 7. The square root and the square cancel each other out. And on the other side, we got x plus 1 squared. So we squared both sides of the equation to get here. And now what we have is an equation that doesn't have any square roots in it. So we can solve that equation. And the way you do it, well, if these parentheses are kind of getting in the way, so let's get rid of these parentheses. X plus 1 squared is equal to x squared plus 2x plus 1. Where that comes from is x plus 1 times x plus 1. If you use FOIL, you'd get x squared plus 2x plus 1. That's equal to x plus 7. And the way you solve an equation when you have x squared terms and x terms is to set it equal to 0. So to set this equal to 0, I'll subtract x from both sides and subtract 7 from both sides. And that'll give me, let's see, I had 2x, I got rid of one of them, so now I just have 1x. I had 1, I got rid of 7, so now I got negative 6. So I got this equation, which to solve I can factor, because the leading coefficient is a 1. If it factors, it's going to look like this. And if it factors, it'll be because I found two numbers that multiply to negative 6 and add to positive 1, the constant term and the coefficient on the linear term. So let's see, to multiply to negative 6, positive 3 and negative 2 would both multiply to negative 6 and add to positive 1. So those will be the two numbers I put here. So what I now have is something, x plus 3 times something else, x minus 2 equals 0. So the only possible way you can multiply together two things and have them equal 0 is if one or the other is equal to 0. So from here, I can split this up into these two equations. Either x plus 3 equals 0, in which case x equals negative 3 if I subtract 3 from both sides of the equation, or x minus 2 equals 0, in which case x equals 2. So those are my answers? Not quite. I kind of misled you as I was going through these steps. It's this step here where I squared both sides of the equation. You can't really square both sides of the equation, or if you do, you have to be a little bit careful. Essentially, some information gets lost. So what I'm saying is, negative 3 is not the same as 3, for example, but if I square negative 3 and I square 3, in either case I get 9. So I might have started out with two things that weren't equal, and then when I squared both sides they became equal, and so I solve and get these answers, but maybe they're not answers. So there's a couple ways to do that. You can fix that step algebraically when you're going through, but probably an easier way to do it is just check your answers at the end. So let's check. Maybe I should switch colors so this doesn't look like it's part of the original problem. Check our answers. X equals negative 3. Well, let's see, if that's an answer, then the square root of negative 3 plus 7 minus 1 better be equal to negative 3. Change all the x's into negative 3's. Negative 3 plus 7 is 4. Square root of 4 minus 1 equals negative 3. No, I don't think it does, because the square root of 4 is 2, and 2 minus 1 does not equal negative 3. So this is not a solution. So what about 2? Well, let's check. To check x equals 2, we'd plug that into the equation. So I got the square root of 2 plus 7 minus 1, and I want to figure out if that equals 2. Well, will turn out it does, because the square root of 2 plus 7 is the same as the square root of 9, and the square root of 9 is 3. And sure enough, 3 minus 1 equals 2. So I only get one answer, x equals 2. All right, moving on. Complex numbers, completely different topic. Well, related topic in some sense, but for our purposes, a different topic. We're given complex numbers and asked to subtract them, multiply them, and then divide them. Subtracting them, you basically just treat the I as though it were a variable. So really, instead of thinking about this as the difference of two complex numbers, think about it as 4 terms, and you're trying to combine like terms. So I get 2 minus 5i minus 3 minus 4i. If I take this negative and distribute it to each of the terms in these parentheses. And now if I combine like terms, 2 and negative 3 gives me -1. And -5 of these I things minus 4 more of these I things would give me -9 of these i's. And since this is now written in a plus bi form, I have my final answer. It says up here, make sure you express it as a plus bi. Okay, so that's multiplying, or that's subtraction. How about multiplication? For multiplication, it's kind of similar. You kind of think about the i's like it's a variable again. If you were multiplying together two things and this was 2 minus 5x times 3 plus 4x, you'd use our box method or FOIL this out. And if you did, you'd get 6, let's see, 2 times 4i would be 8i. -5i times 3 would be -15i. And then -5i times positive 4i is -20i squared. So if you were just treating it identical to how you treat variables, you'd get here. I guess you could take it a step further and combine like terms. 8i minus 15i gives you -7i. If they were just variables, you'd stop here. However, we don't stop here because I squared is equal to -1. The way we define I is it's the square root of -1. So if you square both sides of that equation, you get the identity that I squared equals -1. So instead of writing I squared right here, I could really write -1 right here. So -20 times -1 would give me +20. And now if I combine like terms, the 20 and the 6 give me 26 minus 7i. This is written in a plus bi form, so this is my final answer. What about division? Well, it turns out that division is very similar to multiplication. There's sort of a trick to it, and if you know the trick, you essentially just turn a division problem into a couple multiplication problems. And so what the trick is I have a fraction here. So what I could do is multiply the top and the bottom of the fraction by, if I multiply the top and the bottom by the same number, I'm not changing the value of this fraction. So I can pick any number I want and multiply the top and the bottom by that number. I'm going to cleverly pick the conjugate of the denominator here. So the conjugate is the same as this thing, except you switch the sign in between the two terms. So instead of 3 plus 4i, it would be 3 minus 4i. And if I multiply that to the bottom, I better multiply it to the top also, so I'm not changing the value of this fraction. And if you do that, see up top, 2 times 3 is 6. 2 times -4i is -8i. -5i times 3 is -15i. Seems familiar. Have I done this one? No, I guess I did similar up here, but not quite the same. -5i times positive 4i would be -20i squared. And so now if I combine, well, that's just the top. Down on the bottom, I got 3 plus 4i times 3 minus 4i. You could do those same steps, or you can recognize that you're multiplying by the conjugate. So the outer and the inner in FOIL will cancel each other out. And so all you'll get is 3 times 3 is 9, minus 4i times 4i is 16i squared. So if we simplify this a little bit, again using the trick that I squared equals -1, we can say this is 6, -8i minus 15 more I gives me -23i. And then since I squared is -1, instead of minus 20i squared, I can write plus 20. Similarly on the bottom, instead of minus 16i squared, I can put plus 16. And so what I get is 26 minus 23i, 20 and the 6 giving me 26, divided by 25. This is great. If you get to here, honestly, I'm pretty happy. But it's not in a plus bi form yet. To get it into a plus bi form, rewrite it as 26 25ths minus 23 25ths of I. So really, in order to get it into the right form, we'd want to go one step further and write it like this. Although if you left it here, I'd be pretty happy, and you probably get most of the credit anyways. But technically, since the instructions say make sure your answers are complex numbers, we should go all the way down to here. But I guess that's it. That's the end of this quiz, so I'll stop the video here.